So now I'll find the mixed strategy Nash equilibrium for this game. And again, recall that our goal is to find a probability for C1 and a probability for C2. Probability that player 2 plays C1 and the probability that player 2 plays C2. And then the same for R1 and R2. Probability that player 1 plays R1, call that probability Q. And the probability that player 1 plays R2, we'll call that probability 1 minus Q. Okay, so we want to figure out a probability that's going to make the expected utility of R1 the same as the expected utility of R2. And then we want to do the same for C1 and C2. Okay, so for R1 and R2, let's see, we just care about those values. So the expected utility of R1 is going to be P times 6 and 1 minus P times 3. And the expected utility of R2 is going to be P times 2 and 1 minus P times 4. Okay, then we want to set these equal to each other. So we have 6P plus 3 minus 3P equals 2P plus 4 minus 4P. So that's that. That's that. Okay, so let's see. This is going to be 3P plus 3 equals 4 minus 2P. So we'll add 2P to both sides. That's going to give us 5P plus 3 equals 4. Subtract 3 from both sides, which is going to give us 5P equals 1. So therefore, P equals 1/5. Okay, so player 2 is going to want to play C1 1/5 of the time and C2 4/5 of the time. Okay, so C1, we want to play that 1/5 of the time, and C2 4/5 of the time. Now, for C1 and C2, so the expected utility of C1 is going to be Q times something plus 1 minus Q times something. Okay, so for C1, we have -6 and -2. And for C2, we have -3, -4. Okay, so again, we want to set these equal to each other. So we start with that. So let's see. Oops, we don't start with that. What did I do wrong here? That's just 2. Okay. And this is going to be q minus 4. So we will add 4q to both sides. And then add 4 to both sides. So q equals 2/5. Okay, so player 1 is going to want to play R1 2/5 of the time and R2 3/5 of the time. Okay, so our Nash equilibrium is 2/5 R1, 3/5 R2, and then as we already said, 1/5 C1 and 4/5 C2. Okay, and then same for this one. Okay, so for R1, so P times something, 1 minus P Okay, so for R1, P times 4, 1 minus P times 2, and then 6 and 0. Okay, that's all going to be 0. So let's see here. This is going to be 2P plus 2 equals 6P. Subtract both sides. So it gives us 6 minus 4P. Divide both sides by 4. So P is going to be 1/2. Okay, so player 2 wants to play C1 1/2 of the time and C2 1/2 of the time. Okay, so 1/2 C1, 1/2 C2. Okay, now for player 1, we have Q times something, 1 minus Q times something. Okay, so for C1, the expected utility is going to be Q times 8 and 1 minus Q times 2. and then 0 and 8. Okay, so 8q plus 2 minus 2q is going to equal 0 plus 8 minus 8q. All right, so this will be 6q plus 2 equals 8 minus 8q. Let us add 8q to both sides. So that gives us 14q plus 2 equals 8. We'll subtract 2 from both sides. So 14q equals 6. Q equals 6/14, which equals 3/7. Okay, so player 1 needs to play R1 3/7 of the time and R2 4/7 of the time. Okay, so that's our mixed strategy Nash equilibrium.